All right, so I want you to realise this. Rational denominator. If your denominator is irrational, then your method for solving this problem is incorrect. That's the first thing I want you to remember. The second thing is that it's in simplest form, and we're going to do this question here. Now, what I wanted to say to you is that if I had 3 root 2 plus root 5, and then I had that squared, what you'll notice is that 3 root 2 times 3 root 2 is going to be 3 times 3 is 9, is going to be 18. That's all fine. But look what's happening. I've got this expression. I've got 3 root 10. And then if I do it again over here, I've also got 3 root 10. They're not going to cancel each other out. If you have the difference of 2 squares, however, you should have remembered that a minus b times a plus b is equal to a squared minus b squared. The middle term is effectively cancelled out because we've got this minus b times a and an a times positive b. And that's what we're doing when we're rationalising the denominator. So what we have to do is whenever we want to balance these things out, we have to write it out again with an equal sign. A lot of people just lose that equal sign, and rather than have plus times 1, we can actually go times 3 root 2. We've got to look at this sign here. Let's change that to a minus. That's all we're doing. But be careful, you cannot multiply it by root 2. You cannot multiply it by root 2 plus 5, root 5, because we know that that means that we're not going to cancel out the surds. It means it's still going to be irrational. So we've got 3 root 2 minus root 5 on the top, and on the bottom is 3 root 2 minus root 5. Notice that it has to be the same on the numerator and denominator, because otherwise you've created an imbalance. That's what we do. We can't create an imbalance in mathematics. Now what we have to do is expand. 3 root 2 times 3 root 2 is 18, because 3 times 3 is 9, and root 2 times root 2 is 2. That's what students make the mistake of. They leave that as, say, I don't know, sometimes they do 6 root 2 or all sorts of things. Root 12, 6 root 12 or whatever. They do all sorts of crazy things. We've got we've got 3 root 10, and then we've got, what else have we got? We've got minus 3 root 10, and then over here we've got a minus 3 root 10 again. So how many root 10s do we have? 3 minus 3 minus 3 is minus 6 root 10, and root 5 times root 5, it's positive though because of the negative here. Okay, negative times a negative is a positive. So we've got positive 5. On the bottom, we discussed that it was 13. 9. This was a root 5, by the way, wasn't it? 18 minus 5 is 13. So now what we have to do is simplify. I don't want you to leave that. The only thing we can do, though, is 18 plus 5 is 23. So your answer is 23 minus 6 root 10 over 13. Can I get a show of hands of students that got that eventually? Okay, I hope you're feeling a little bit better. I'm going to pause this video now. I'm going to give you another question. All right, now you can see that if I just bring this up, sorry, there you go. Now let's have a look. Oh, that's annoying. Can you unplug that, mister? Thank you. Sorry. He's trying to charge his calculator, but it's coming up with that. I'm not sure what we can do with that, matey. All right, so you should always draw a diagram. I'm telling you now that if I was feeling generous, if this is worth 3 marks, at least if you did that, we could potentially give you a mark, and it also helps frame your understanding. Importantly, though, what students do is they get the whole a squared plus b squared equals c squared mixed around. A lot of the time when they're solving for C, they know how to do it. But what are we solving for? Are we solving for C? We're solving for A. Now, you could be solving for B in your problem. It's not going to make a difference. But what we're going to need to do is going to rearrange. Now, be careful because we can only use this for a right-angled triangle. Pythagoras' theorem is only for, guys, too much background noise, is only for a right-angled triangle. So what we need to do is I'd like to find A squared. Now I know though, I know what B and C are, so let's go ahead and put those in surd form, please. A squared, I'm going to do this in a couple of lines, plus B squared, which is 4 root 3 plus 2 squared is equal to 8 plus root 3 squared. Now this is where a lot of students make mistakes because what they do, can I ask how many expressions, how many terms are we going to have, how many terms are we going to have when I expand out 4 root 3 plus 2? 4 terms. If you're getting 2 terms, it's because you're not expanding it out properly. Remember that. So what I'm going to do is I'm going to write this out like so. 4 root 3 plus 2 times 4 root 3, oopsie, get the eraser, oopsie, plus 2 is equal to 8 plus root 3 times 8 plus root 3. Now, I'm going to pause the video now, and can I ask how many students actually did that? All right, so I'm gonna honour what you guys have just said, and what you were saying is you want to get A squared is equal to C squared minus B squared. Is that correct? Yeah. Which means that you've got 8 root, that's perfectly fine. Okay, let's go ahead and do that. All right, 8 plus root 3 and minus 4 root 3 plus 2. Now don't forget that minus because that's what some of us do. Like so. Now, remember that when I have these surds, this surd expression, we're going to have 4 terms. They might simplify to 3 terms. We've got 8 times 8, we've got 8 times root 3 times 8, and root 3 times root 3. And can I get a show of hands, the number of students that did not do that? Yeah, there's at least a few of you there. Okay, so 8 times 8 is 64. 8 times root 3 is 8 root 3, but we've got another 8 root 3. So how many root 3s do we have? 16 root 3 plus root 3 times root 3. Be careful. It's 3. It's not 9. Now, we've got a negative symbol out the front. The use of square brackets is a good thing to do because that means that everything inside that is multiplied through by the negative. 4 root 3 times 4 root 3 is 16 times 3, which is 48. Plus, we've got 2 times 4 is 8 root 3, plus 8 root 3 is 16 root 3, plus 4, because 2 times 2 is 4. Are we following me so far? Good. Now what we've got to do is, well, everything in this bracket is subtracted. But I'm going to simplify. I'm going to look at the constants first. 64 plus 3 is 67. 48 and 54 is 52. 67 minus 52 is 12, isn't it? 67 minus 52 is 12. 15. Oh my God, I'm having one of those days, and it's now recorded on video on YouTube. I'm a maths teacher and I'm just saying 67 minus, what did I say? Minus 52 is 12. All right. I should be fired. If Mr. Foley watched this, I'd be fired, wouldn't I? All right. Now, sorry, it's not easy getting on the whiteboard, I can assure you. All right. Now, look at this. Isn't this fantastic? Isn't this fantastic? We've got a 16 root 3, and I've got a 16 root 3 which is subtracted. Wow.
It's a plus.
Hang on a minute. You're saying it's a plus, but everything in this is multiplied by a negative. So the answer is what? 15. The answer is 15. Can I get a show of hands? Those students got 15. Less than half the class.
Wait, I did.
Now, I'm going to pause this video. Oh no. What? Now, we've just had a class discussion. All right, I am not the world's dumbest maths teacher, am I? Am I the world's dumbest maths teacher? I'm sorry. A squared is equal to 15. We need to take this. We gotta go the old square root, don't we? The old square rootski. So A is equal to the square root of 15. Is that right? Thank you. I gave some of you a heart attack, didn't I? Okay. Shh. Thank you. Now, area of a triangle, area, half base times height. This is our base, this is our height. We don't even need to use the hypotenuse. So the area, therefore, is equal to a half times 4 root 3 plus 2 times root 15. Now we can do this in one line if you like, because 4 root 3 times root 15 is 4 root 45. And 2 times root 15 is 2 root 15. And then that's all times a half. So if you like, you could have it over 2. I'm just going to leave the half out for the time being. Okay, it's a half times that. Now what I need to do is I need to go into the next line, or no, we'll go down here. So now what we need to do is simplify what's inside the brackets. 4 root 45, we're looking for a perfect square that goes into that. Are we? 9 times 5, thank you. So what we've got is that's 4 square root of 9 times 5 plus 2 root 15. Now what we can do is we can apply that. So the square root of 9 is 3. 3 at the front makes that a 12. So we've got a half times 12 root 5 plus 2 root 15. Then we apply the half at the end, because a half times all of that is going to be a half times 12 root 5 is going to be 6 root 5. And a half times that is just plus root 15. Is that the answer, ladies and gentlemen?
So you don't touch that?
Yes. You can't do anything really to simplify. Okay? You could go ahead, and we know that root 15 is equal to root 5 times root 3, but that's not really going to help us with this problem. So leaving it in this is exactly fine. In exact values, please don't go rounding off, because you don't even have a calculator when you do this. I'm going to pause the video now and give you the next question. 3, here we go. All right, now this one, I could have got you to do it in your calculator, and I want you to first of all realise, though, that your assessment is not a calculator assessment. However, we want you to know how to use it on the CAS. Now the CAS calculator, the good old menu 3-1, that is the fastest way to do this on a CAS. Menu 3-1, and I'm going to show you that, because if I go to menu 3-1 and that goes to solve, I can only solve an equation. I can only solve an equation. So I have to have an equal sign. 2 times 3 to the power of x is equal to 2 over 27. But I'm telling you now, I'll show you the calculator, but it's actually faster to do it by hand. Okay, so what we've got is 2 times, is it 3 to the power of x?
Yeah.
2 times 3 to the power of x. And what's that equal to? 2 over 27. Now have a look at this. You've got a little fractions button, which is this thing down here. If you press Control and the division symbol, look what happens. Control and the division symbol, a fractions icon comes up. And that is equal to what? 2 over 27. Now, be careful, because what have I missed out on? the comma x. The calculator is absolutely silly. It does not know what it's doing. However, if you tell it, go find x for me, that's what I'm looking for, the calculator will go, yeah, x is negative 3. But I'm going to show you, first of all, just pure algebra, we'll just do this here. 2 times 2 over this side and 2 over this side, they're going to cancel out because it's 2 times on the left. Be careful though, you can't go cancelling out things if I had a 3 on the other side, or 3 times, because then you've got to apply your index laws. Guys, really? So what we're going to do is we've got 3 to the power of x is equal to 1 on 27. But what is 1 on 27 in terms of a base of 3? 3 to the power of? Negative 3. So 3 to the power of x is equal to 3 to the power of negative 3. X is equal to? Negative 3. So you didn't need a calculator. Now, this one, I'll get you to hold your questions till the end, but we're applying 2 laws. Law 1 states that 2 logarithms of the same base added together without a constant at the front, when we add the 2 logs, we bring them together. In other words, we can multiply this a and b. Not in this situation. What does law 3 state? What is law 3?
The constant needs to be made negative.
You can get the constant at the front, you can bring it back inside the logarithm, make it a power, or you could do it in reverse. So what we're going to do is we're going to do that. So this expression over here, we're going to say is now those 2 expressions are equivalent. Okay? Now I've got a log 2 of b, log 2 of b, and if I was to just get those expressions together, we know that that is using law 1, log 2 of a squared b. But the problem is we now have this log subtracted. Okay? But when we have a log subtracted, what do? We have them on the same base, but we can then, it's over a minus b, and I believe we need to review our log laws. Okay? The answer was a. Can I get a show of hands, the students that got a? I think we need to revise our log laws. No, actually, good, D. Whoa. The answer's D. The difference is, look at this. Log 2 over log 2 is not like cancelling out fractions. Log 2 over... Just one sec. Log 2 a squared b over log 2, please, you're going to write this in your bound reference. You're going to make this and you're going to write it really big. Does not equal log 2 of a squared b on a minus b. You can try it in your calculator. You could try log of 7 on 3. Does that equal log 2 of 7 on 3? Does that equal log 2 of 7 over log 2 of 3? No, it doesn't. I'm telling you now, you just need to review that, please, because that's a fundamental mistake the students make. So the answer again was D. I'm going to pause the video there just whilst I rub this out. Set, go. All right, this one, as I said now, I've done all the working on the board. You can see it up there again if you would like to stop and maybe have a look at it later. But let's do it. I told you that 2 to the power of 3 on 2. The hint was that 2, we want to find the base of 2. So what I'm going to do is change that 16 to 2 to the power of 4 to the negative 3 on 4. And as I told you, that 2 over here, this guy, he's just chilling out. He's just like, yeah, I'm relaxing. Don't worry about him yet, but you can't drop him off. Okay, you can't just drop him off. He is still there. He's like, I want those 2s to go find a buddy. All right, we've got to do something to the brackets, or inside the brackets. So we've got 2 to the power of 3 over 2 times, let's apply this out, and we went through this just before, so I won't go through it again. 4 times negative 3 over 4 is negative 3. 2 to the negative 3. I didn't really need that bracket, but anywho. Okay, and then that's squared. So then what we've got to do is let's work out inside the brackets. I've got 2 to the power of 3 on 2 times 2 to the power of negative 3. And we discussed that that is 2 to the power of negative 3 on 2. And then that is squared. And then negative 3 on 2 times 2 is 2 to the power of negative 3, which is not negative 1/8 or negative 8 or anything like that. It's 1 on 2, if you like, 2 to the power of negative 1 to the power of 3, which is equal to 1 over 8. And finally, this one, you were saying, how did you do that so fast in your head? Because I'm applying my log laws, because I've practiced them a little bit more than you. Log 5 of 125 minus log 5 of 1/5. Well, what we need to do is we need to go, well, I've got a base of 5, so the first thing I want to see is if I've got like maybe something 5 to the power of something. Now, as it turns out, 125 is 5 to the power of 3. Now what I want to do then is 5 to 1/5 is the same as 5 to the power of negative 1. Now the good old law 3, states that I can get this out the front. So therefore that simplifies to 3 log to the base 5 of 5 minus log to the base 5 of 5. Well, this negative 1 needs to come out the front. Okay, so that needs to go over here. So what can I do then? Negative 1 times... What happens to this sign here? It becomes a plus. Okay, and then we can now say that we've applied that rule. Now, what we've got left is... Oh, that's an og, not a log. Now it's a log. Now, what we've got to do now is we've got to simplify this. But remember that one of those really basic laws which you need to remember is log to the base 5 of 5 is just 1. Because 5 to the power of what is 5? 5 to the power of what is 5? 1. And then 5 to the power of 1 is 5. So the answer is 3 plus 1, which is equal to 4. Does that make sense? Well, even if it doesn't, I think you need to maybe watch this video again. I'm going to pause it now. But the thing is, Sophie's just brought up a really good point, because guess what? There's a method 2, but the problem is with my method 2, that method 2 is just, there's not a problem with it. It's just the fact that I liked my method, so I've chosen to do that. So let's do method 2. Method 2 is this. We're applying what law? Law 1, 2, 3. Which law are we applying? 2. Which is saying that if I've got 2 logs of the same base without a constant, then what I can do is I can get those and I can say that that is equivalent to log to the base 5 of 125 divided by 1 over 5. That's perfectly fine. Now, if you've got a fraction like that, that 5 essentially goes up there, or if you want to do it long ways, 125 divided by 1/5, flip the sign, times... How were you taught? What was the thinking behind that? Like flip and reverse? What is it? Yeah, I'm not sure what the mnemonic was to remember it or whatever, but either way, that's 625. So what you've got is log to the base 5, 625. Now, it's asking us to evaluate, right? Now, we haven't evaluated it yet. 5 to the power of what is 625? Now, if you didn't know that because you didn't have a calculator, you're probably best to use my method, because my method meant that I didn't have to do any silly calculations like that. Okay? So you choose, up to you, method 1, method 2, whatever you prefer. Stop.